only. Your home plate for tonight is 6 problems, and make sure you copy the instructions because each pair of problems have different instructions. For example, the first two, numbers 1 and 2, it says solve each quadratic equation by graphing, square root, and factoring. So how many different methods? 3. That's for number 1 and number 2. For 3 and 4, it says solve each quadratic equation using square roots, only one method. And number 5 and 6, solve each quadratic equation by factoring. Copy those. All right, once again, the home plate for tonight is only 6 problems, only. Okay? All right, let's move on. Our objective for today, I can solve and graph quadratic equations. Once again, I can solve and graph quadratic equations, starting over the main concept for today. Bless you. Quadratic equations, that is correct. That goes inside your Freyer model. Copy that in your Freyer model. And the Freyer model should look something like this. Quadratic equations. Definition. What are quadratic equations? Quadratic equations are 2 variable equations where the highest degree is 2. Quadratic equations are 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. Quadratic equations are 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. Say neighbor what quadratic equations are? Examples. We got x squared plus 3x plus 2 equals y, x squared minus 9 equals y, and y equals 3x squared minus 11x plus 6. Copy that. All right. Writing utensils down, look up to the screen. I'm going to go over the examples with a definition, but before I go over that, I want to clarify some of the terms that we have in the definition. I'm pretty sure by now we understand what a 2 variable equation is. Is that correct? Yeah, Mr. Q, because we covered that at the beginning of the school year. All right. So here the only thing to think about is degree. So let me recap degrees. So write your utensils down, look up. You don't have to copy this. I'm just going to elaborate on degrees. When writing expressions, each expression has a degree. Focus, please. Each expression has a degree. So if I was to write an expression such as x squared y cubed plus xy squared plus x, it's another 2 right there. Bam. Plus x minus 2. This is an expression because there are no equal signs or inequality symbols. Everybody agree? All right. We need to find the degree of this. This is what we call a polynomial because it has a lot of terms or a lot of parts. That's where I got confused. Okay, well, let me show you. When you start reading it from left to right, each part stops whenever there's a plus or a minus. I'm going to start reading, and it stops right there. So that's one part. Here's a plus sign. I start again, and it stops right there. That's 2 parts. 3 parts, 4 parts. Each part is called a term. What is it called? Term. So this one has 4 terms. To find out the degree of this expression, or also known polynomial, we need to identify the degree of each part. How do we do that, Mr. Q? By adding the exponents on the variables. First one is 5 degrees. The second one is 3 degrees because 2 plus 1 is 3. This one is 1 degree. And this one is 0 because there is no variable. That is correct. Now that I have my degrees laid out, the degree of this entire expression is the highest degree of the whole thing. What's the highest degree? So this polynomial is to the 5th degree. You're like, piece of cake. Now that I went over degrees, and now what we understand what it means, let's go to our examples. It says two variable equations where the highest degree is 2. Look at the first example. What is the degree of this term? This one, 1. We just add the x1s on the variables. This one, highest degree. That's why it's an an equation, two variable equation, highest degree 2. Do we have two different variables? Yes, x and y, x and y, x and y, highest degree 2. Pretty clear? All right, now that we know what they are, let me show you what they are not. Before you copy that, tell your neighbor why each one of those is not a quadratic equation. Why is it not? All right, the first two, Cindy, why are these not quadratic equations? Okay. They don't have two variables, but specifically what's missing? Yes, the y. The equal sign. These are not equations. These are expressions. All right. That means that this one is not because of y, Danica. It only has one variable. That's the only reason. It's what? It's missing the y, yes, that's one thing. Anthony? The highest degree is only 1, which means if we have any expression or equation that's to the first degree, that's what we call a linear. Okay? Copy that and come up with at least 2 or 3 hashtags. What is a quadratic equation? Hashtag what? Hashtag what and hashtag what. Laisha, hashtag what? Hashtag highest degree 2. Hashtag what? Edgar. 2 variable equations. That pretty much covers it, right? Yeah. Well, hashtag math. No. Believe it or not, in the pop parties that I include prayer models, guess what they write? Hashtag BAM. Wow. Yeah, other people will get upset with that. All right, here we go. Copy this one on your paper. Example 1. Solve using square roots. Solve using square roots. X squared minus 9 equals y. Just copy that. Here we go. Writing utensils down. Look up to the screen. I'm going to go over the entire process, but I want you to think about it in regards to what would you write as your process in general for any type of these problems. Okay? Once again, you already know these. I'm just trying to recall stuff that you have. Okay? Here it goes. Writing utensils down. Look up to the screen. Pretty clear? Step 2. Pretty clear? Step 3. Okay, before you copy it, think about the steps. What would you explain to somebody the general process is for these kind of equations? Talk it over your neighbor, please. Yeah. Guys, I don't want to hear add or subtract this. I want to hear a general term. What would be a general term for the second step? Solve for x is the whole thing. Isolate the variable. Yes? All right. Copy that, please. As you're finishing up, I'm going to forward your screen, lock your toolbar, do that one on your screen and send it in as soon as you're done. Copy it and go. Copy this one, example 1 mega cube. So now that we have a process in our noodle, it's 3 steps, right? Let's see, Victor, what would be our first step for a process? Set y equal to 0. Step 2. Yes. Isolate the variable, yes. And step 3, everyone, square root. So I'm trusting that if you follow that process, you will be able to solve that one by yourself. Copy that on paper and solve it, please. I'll give you some time. 40 seconds. Copy and go. Should be done by now. Here goes the process. 3x squared minus 27 equal to 0. So step 1 is changing y to 0. Step 2, isolate the variable. So that means we add 27 to each side. 3x squared equals 27. But wait a minute, there's still a number there. It's multiplying the inverse is 2, divide by 3. X squared equals 9. And of course our last step is to take the square root. X equals plus minus 3. And have you got that? We got this, yes? All right. So now that we have our 3 steps embedded in our noodle, I trust that you can do this next one by yourself on the screen. Lock your toolbar. You got 35 seconds. Copy and go. Let's see. It looks like we got this, yes? Bam, let's go. Yeah, x equals plus minus 5. Look at this one. If you were a teacher, what minus what? Minus 1 point. That is correct. Process is correct. Just at the end, you forgot the plus minus. Be careful with those. All right. Example 1, super duper cube. Copy that one. Now this one, the process is still the same, except for when you get to the end, listen to what I'm about to say. When you get to the end, look at it and see if you can do anything else. Okay? I'll give you 45 seconds for this one. Copy and go. All right, here it goes. Step 1, change y to 0. Step 2, isolate the variable. Plus 16 plus 16, 2x squared. Oh, sorry. Let it go. Equals 16. Still not isolated. Divide by 2. X squared equals 8. And last step, square root, x equals plus minus square root of 8. However, I said, if you see something, see if we can do anything else. Look up. Who sees this? Can we simplify that? Tell your neighbor how to simplify it, please. That is correct. X equals plus minus square root of 4 times 2. X equals plus minus square root of 4 times square root of 2. X equals plus minus 2 square root of 2. We good? Yes. Thank you very much. Cindy for Presidente. I want to see every little step. Okay? All right. Next. Copy this one. Example 1, Michael Jordan cubed. Negative 5x squared plus 9 equals to 0. And once again, go through your process and see if at the end you can do anything else. I'll give you some time. 46 seconds on this one. Copy and go. Here goes the process to make sure we got it. It's already equal to 0, yes? All right. So, isolate the variable. So, minus 9, negative 5x squared equals negative 9. Good looking out, Colton. Divide by negative 5, divide by negative 5. X squared equals 9 over 5. Next, square root. Square root. Does this look familiar? X equals plus minus square root of 9 over 5. Can we leave it like that? No. X equals plus minus square root of 9 over square root of 5. Am I done? No, we need to rationalize the radical. So that means we need to multiply times square root of 5. Oh, square root of 5. My bad. I skipped a step. Unite. This is 3 square root of 5. Now we multiply times square root of 5. We end up with 3 square root of 5 over, what is 5 times 5? 25. Now we just simplify this one. X equals plus minus 3 square root of 5 over 5. And if you got that by yourself. Cool. Woo! We good? Yeah? So let's think about the process. There were 3 steps, but now we're adding one last step. Think about the previous example. And this example. What would we call that in general terms, that last step? Simplify. So now we have our 4 steps. We got it? Step 1, y equal to 0. Step 2, iso the variable. Step 3, square root. And step 4, simplify. Man, it didn't remind me of me in kindergarten. All right, let's move on. All right, copy this one. Solve by factoring. Example 2, x squared minus 9 equals y. Just copy it. I'm going to go over this process. Now, in your noodle, the word factoring should be triggering something to do. We've been doing this on the warm-ups, right? Factoring, but this looks nothing like what we did on the warm-up. Of course, because it's different. That's why it doesn't look like the warm-up. So write your utensils down, look up to the screen. Here goes the process for this kind. Step 1. Yes? Step 2 and on. Pay attention to this part, please. Write your utensils down when you have time to copy. To factor this kind of equation, notice that we only have 2 terms. When we have 2 terms, it looks kind of weird, so the red flag should be that it's 2 terms and there's a subtraction here. In mathematics, we call that difference. If we are in quadratics, That means this is called difference of squares. What does that mean, Mr. Q? Well, that means that two squares are subtracting, and that's what difference means. And how do you know if it's a square, Mr. Q? Well, we test it. Look up, please. Let's test and see if we can take the square root of this. Can we take the square root of that? Yes. Can we take the square root of this one? Yes. If we can take the square root of both, that means it is a difference of squares. Therefore, what happens when we do square root of 9? We get what? Plus 3 and minus 3. That's why we can actually write our factors already. Equal to 0. This next step is the easy step. Check this out. Look up, guys. If I have A times B equal to 0, what could A be? Let me do that again. This times this equal to 0. What could this one be? Or what could this one be? Either one could be 0, right? That's why this next step is like this. If this times this equals 0, that means this could be equal to 0, or this could be equal to 0. Do we know what to do from there? Yes. Next, can we solve each of these? Yes, minus 3 minus 3, x equals negative 3 plus 3 plus 3, x equals 3. And these are called my solutions. Copy that, please. Any questions on difference of squares? Pretty straightforward, right? Okay. Don't copy this next one. I just want to see if you see it. Don't copy it. We have x squared minus 64 equals y. No, on your screen. Right? So that means it would be what? X squared minus 64 equals 0. And then my two factors will be what? X plus 8, x minus 8 equal to 0. Set each one equal to 0. Solve. Therefore, x equals 8 and x equals minus 8. Okay? All right. So now that we got those, look at this one. To factor this one, does this look familiar? Same. The first step is always the same. Check this out. Power Rangers. What goes on top? 6. What goes on the bottom? 5. Factors of 6 that add up to 5. 2 and 3. You rewrite this into 4 terms. Remember that? Group, factors, and so on and so forth. All right. And lastly, I said lastly, not laughy. Copy this one on paper. Example 3, solve by graph. Hurry up, hurry up. Last one. Mr. Q, this looks familiar. Yes, it does look familiar. That means we need to write it as a system. Remember these? What is g of x? 25. What is f of x? X squared. Do we know what x squared looks like? Yeah, a parabola going through the point of origin. Do we know how to graph g of x equals 25? Yeah, a straight line going through 25. So what is the solution, Mr. Q? The solution is where both graphs intersect at this point and that point. Here it doesn't fit on my screen, but I'm saying when you graph it on your own paper, it would be able to see the intersection. All right? You already have the home plate. Have a good one, guys. Make sure you log out. There is tutoring today. It's free. I know, right? Have a good one. See you guys tomorrow. Bye.